Number the time delusion. You think you know what reality is. You wake up. You go to work. You watch the clock tick forward. You feel yourself aging, your memory stacking up like books on a shelf. Past behind you, future ahead of you, present right here in your hands. It all seems so obvious, so clear, so fundamentally true. Except it's not. None of it is. What you're experiencing isn't reality. It's a user interface. It's your brain feeding you a convenient lie so you can function without going completely insane. Let me start with something simple, something you do every day without thinking about it. You estimate time. How long has it been since breakfast? About 3 hours. How long until your next meeting? Maybe 20 minutes. You make these calculations constantly, and you think you're measuring something real, something external to yourself. But here's what's actually happening inside your skull. Your brain doesn't have a clock, it has a prediction engine. And different people run wildly different prediction engines for the exact same task. Let me give you an example. Ask someone to count to 1 minute in their head. Just sit there and count the seconds. 1, 2, 3, simple, right? Wrong. What's happening in your brain when you do this? Some of you, most of you probably, you hear yourself counting. There's a little voice in your head speaking the numbers. 1, 2, 3, 4. You're literally talking to yourself internally. And here's the interesting part. If someone interrupts you and asks you to actually speak out loud, to say something, anything, your count collapses. The whole system crashes. Why? Because you're using the same neural machinery for both tasks. The counting voice and the speaking voice are the same circuit. You can't run two programs on one processor. But not everyone counts this way. Some people don't hear a voice at all. They see something. Maybe it's a number line stretching out in space. Maybe it's a digital clock display flipping forward. Maybe it's something completely unique to them, some visual metaphor they invented as a child and never questioned. And these people, the ones who see time instead of hearing it, they can count while reading a book. They can sort through papers while tracking the seconds. Why? Because they're using different parts of their brain, visual processing instead of auditory processing. This isn't a minor detail. This is fundamental. Two people performing the identical task, counting time, are running completely different internal programs, and they don't even know it. They both arrive at roughly 60 seconds, and they think they experienced the same thing. But they didn't. The machinery is totally alien. So when we talk about time in physics, we have to throw all of this out. We have to stop asking what time feels like and start asking what time actually is. And the answer is going to make you uncomfortable because it strips away all the poetry, all the metaphor, all the comforting stories you tell yourself. Time is not a river. You love that image, don't you? Time flowing like water, carrying you from past to present to future. It's beautiful. It's evocative, and it's completely meaningless. If time flows, how fast does it flow? 1 second per second? That's circular nonsense. That's like saying a meter stick is 1 meter long. It tells you nothing about the structure of reality. It's just words chasing their own tails. The truth is much stranger and much less romantic. Time doesn't flow. Time doesn't move. Time doesn't push you anywhere. Time is a dimension like space. It's a coordinate system we use to organize events. That's it, nothing more. Imagine you have a notebook. You write events on different pages. Meeting at 3 p.m. on page 15. Dinner at 7 p.m. on page 42. The pages don't move. The notebook doesn't flow. The order is just a structural feature of how you organize the information. Time is the page number. Events are the entries. When we say time passes, we're just reading through the notebook. Now you're going to push back. You're going to say, but I feel time passing. I get older. Things decay. Milk spoils. How can you say time doesn't do anything? And this is where we need to be very, very careful with language, because language is setting a trap for you. Time is not an agent. Time doesn't have hands. Time doesn't reach into your refrigerator and spoil your milk. Bacteria do that. Chemical reactions do that. The second law of thermodynamics does that. Time is just the label we stick on the sequence of events. Saying time caused something is like saying inches built your house. Inches didn't build anything. Carpenters built it. Inches just measure where the walls ended up. Here's another way to think about it. You believe time exists independently of the universe, right? You imagine that even if we deleted everything, every star, every atom, every photon of light, time would still be there, ticking away in the void. This is the Newtonian view. Time is an absolute background, a cosmic stage on which events perform. But this is dead wrong. Time is not independent of stuff. Time is a property of stuff. Time is a measure of change. And if absolutely nothing changes, no particles move, no fields fluctuate, no energy transfers from one place to another, then time stops. It ceases to have meaning. You can't define a second without something to mark it. A pendulum swinging, a crystal oscillating, a cesium atom vibrating. The second is defined by the thing doing the changing. Remove the thing, remove the change, and you remove time itself. This should bother you. This should feel wrong, because you've spent your entire life treating time as this independent thing, this external force that acts on the universe. But it's not. It's more like temperature. Temperature isn't a thing. It's a description of how fast molecules are jiggling. No molecules, no temperature. Same with time. No change, no time. Now let's push this even further. Let's talk about what happens when we take your comfortable, intuitive ruler of time and discover that the ruler itself is flexible, that it stretches and squashes depending on how you're moving and where you are. You think a second is a second everywhere in the universe. You think if you had a clock on Earth and a clock on Mars, they'd tick in perfect synchronization. This feels obvious. It feels like it has to be true. And it's completely, fundamentally wrong. The rate at which clocks tick depends on their velocity and their position in a gravitational field. This is not a malfunction. This is not an error in the clock's design. This is how the universe works. A second on a fast-moving spaceship is not the same duration as a second on Earth. They're different, measurably different. We've checked repeatedly with atomic clocks on airplanes, with satellites in orbit, with particle accelerators. The data is overwhelming. Here's the mental model. Imagine you're driving across a huge flat plain. You can drive north or you can drive east. If you drive purely north, you're making maximum progress northward. But if you turn the wheel and start driving northeast, you're splitting your speed. You're moving a bit north and a bit east. You're not going north as fast anymore because you diverted some of your motion to the east. Now replace north with time and east with space. This is special relativity. You are always moving through the universe at a constant speed. But that motion is split between movement through space and movement through time. If you're sitting still, you're devoting all your motion to time. You're aging at maximum speed, moving into the future as fast as physically possible. But the moment you start moving through space, walking, driving, flying, you're diverting some of that motion away from time. Your clock slows down, your aging slows down. This isn't science fiction. This is engineering reality. GPS satellites move fast, so their time is different from your time. We have to correct for this. If we didn't, your GPS would be off by miles within a day. At the extreme, if you could move at the speed of light, which you can't because you have mass, you would be dedicating 100% of your motion to space. You would have zero motion left for time. For a photon, time does not pass. It's created and destroyed in the same instant from its own reference frame. The universe is frozen. And here's where it gets truly weird. This isn't just about clocks running at different rates. This is about the structure of reality itself. There is no universal now. There is no cosmic present moment that stretches across the entire universe like a blanket. If you and I are standing next to each other, our now is effectively the same. But if you're on a planet a billion light years away and you start moving away from me, your definition of now, the events you consider to be happening right now, slices through the universe at a different angle than mine. What you think is happening right now might be in my future. What I think is happening right now might be in your past. The universe is a four-dimensional block, a loaf of space-time bread. And how you slice that loaf, which slice you call now, depends entirely on how fast you're moving. There is no correct slice, no privileged moment, no absolute present. This makes people uncomfortable. This feels wrong at a deep, visceral level, because your brain is hardwired to believe in a universal now. Your survival depends on it. You need to know what's happening right now so you can respond to it. But the universe doesn't care about your survival instincts. The universe doesn't care that this feels wrong. The universe just is. Let's talk about the arrow of time now, the thing that makes you believe time has a direction. You remember the past. You don't remember the future. You can scramble an egg, but you can't unscramble it. The universe seems to have a built-in asymmetry. Past and future are different. But here's the thing. Most of the fundamental laws of physics work perfectly well in both directions. If you film a planet orbiting a star and play the video backward, it looks fine. The equations don't care which direction time runs. But if you film an egg dropping on the floor and shattering and then play that backward, everyone immediately knows you're cheating. The egg doesn't spontaneously reassemble itself. Why? What's the difference? The difference is probability. The difference is entropy. There are billions of ways for an egg to be broken. Yolk here, shell there, splattered in this pattern or that pattern. But there's only one very specific arrangement where the egg is whole and intact. So as the universe evolves, as particles bounce around and interact, they naturally drift from the highly organized, low probability state to the disorganized, high probability state. We call this entropy increase. And this is the only reason you perceive an arrow of time. You're watching the universe shuffle the deck. You started with a sorted deck, and every moment that passes is another shuffle. You can't unshuffle by accident. The probability is too low. So your sensation of time flowing forward is really just your brain registering the increase in disorder. You're a mess detector. When you distinguish past from future, you're really distinguishing less messy from more messy. If the universe were in a state of maximum entropy, where everything is evenly distributed and nothing interesting is happening anymore, your brain wouldn't be able to tell past from future. There would be no eggs to break, no memories to form. In a heat-death universe, the arrow of time vanishes. Now, let's go backward, all the way backward. If time is a measure of change, what happens when you rewind the universe to the very beginning? The universe is expanding. We can see the galaxies moving apart. Run that backward and they get closer. The universe gets smaller, denser, hotter. Eventually you hit a point called the Big Bang, where our current understanding of physics breaks down completely. And here's the question that keeps cosmologists awake at night. Does it make sense to ask what happened before the Big Bang? If time is just a property of the universe, a way of ordering events inside the universe, then asking what came before the universe might be like asking what's north of the North Pole. The question sounds grammatical, it sounds reasonable, but geometrically it's nonsense. There is no north of the North Pole. There may be no time before the beginning of time. This creates a profound tension between what we want to be true and what the math tells us. We desperately want a backstory. We want the timeline to extend forever in both directions. It's hard to accept that the tape measure might just start, that there's a first page in the notebook. Our psychology rebels against it, even though our physics might demand it. Go back to those people counting in their heads. The voice people and the visual people. They're both trying to impose a rigid, linear structure on their experience. We do this because we have to. We evolved to track duration, to anticipate events, to plan, but we did not evolve to understand the true nature of time. Our brains are efficient survival machines, not precision instruments for perceiving reality. And this is why physics is so hard. This is why relativity feels impossible, because you're trying to translate the high-level language of the universe into the low-level language of your monkey brain. You're trying to fit a four-dimensional object into a three-dimensional intuition. Doesn't work. The shape is wrong. The pieces don't fit. When you learn about time dilation or space-time curvature or the relativity of simultaneity, you're not just learning new facts. You're being asked to delete your operating system. You're being asked to throw away the voice counter or the visual tape measure or whatever private mental machinery you've been using your entire life. And your brain fights back because this machinery is how you survive. But here's what's beautiful. Even though your intuition is wrong, even though your internal clock is a biological hack, even though time is this weird, flexible, relative dimension that bears no resemblance to how it feels, the equations work. The predictions match reality. We can build GPS satellites. We can measure gravitational waves. We can see the effects of time dilation in particle accelerators. The universe is stranger than you think, but it's also more precise, more mathematical, more knowable. You just have to be willing to let go of the story you've been telling yourself. You have to be willing to admit that what feels true isn't always what is true. And when you finally make that leap, when you stop trying to force the universe to match your expectations and instead let the universe show you what it actually is, something shifts. The confusion doesn't disappear completely. The weirdness doesn't go away, but it stops being threatening. It starts being fascinating. You realize that time isn't a river. It's a dimension. It's a label. It's a way of organizing change. And once you accept that, once you really accept it, the universe opens up, not because it got simpler, but because you stopped fighting it. So the next time you count seconds in your head, whether you hear a voice or see a tape measure or experience something else entirely, remember this: that counting is not time. That sensation is not reality. It's just your brain doing its best with the tools evolution gave it, and that's fine for catching the bus or boiling water. But if you want to understand the universe, you have to go deeper. You have to look past the interface. You have to see the code underneath. And the code is strange. The code is beautiful. The code is nothing like what you expected, but it's real, and that makes it worth understanding. Let me give you one more thing to think about. You think you experience time smoothly, continuously, like a movie playing at 24 frames per second. But that's not what's happening. Your brain is sampling reality in chunks, assembling a coherent narrative from discrete snapshots. The smoothness is an illusion, a post-processing effect your visual cortex applies to make the world comprehensible. Different sensory systems run at different sampling rates. Your visual system updates faster than your auditory system. Your sense of touch has its own refresh rate. And your brain has to constantly synchronize all these different data streams, lining them up so that you experience a unified now. But this synchronization isn't perfect. There's lag. There's buffering. There are moments when your brain is literally showing you the past and calling it the present. Musicians know this. When you're playing in an orchestra, you have to compensate for the fact that sound takes time to travel. The person sitting 30 feet away isn't hearing the same now you're experiencing. They're hearing your past. Good musicians learn to anticipate this, to adjust their timing based on where they're sitting. They're doing relativistic calculations without knowing it. This is the gap. This is the chasm between human experience and physical reality. And we can't close it by making physics more intuitive. We can only close it by making ourselves less attached to intuition, by recognizing that what feels right is often just what's familiar, and what's familiar is just what helped our ancestors survive long enough to reproduce. So yes, count your seconds. Use your voice or your tape measure or whatever works for you. boil your eggs, catch your buses, live your life. But know, deep down, that the timer you're using is just a tool. It's not the territory. It's a map. And the territory, the actual structure of space-time, is weirder and more wonderful than any map could ever show.